So in question 1 here, we're being given a vector equation of a line, and they're asking us to explain why these 3 different m's, 3 different direction vectors, are all acceptable for this line. Well, the whole idea of a vector equation for a line is you need to have a point, which we do, and you need to have a direction. And the direction that they were giving us was 1/3, 1/6. Well, if I think of that as components, and just the easiest possible way here, 1/3, 1/6 would be like pointing that way. I can change that by multiplying that by some scalar, any scalar I want. So for example, in the first one here, they've given us point -2, -1. Well, they said, well, let's take an a value of -6. And if they do that, -6 times 1/3 and 1/6 will give us -2 and -1. So all they've done is create a collinear vector of the exact same direction. So -2 on our lines here, -2 and -1. And as it's down here, well, that's the same direction, right? Our line's going to keep going and going and going in both directions forever and ever and ever. So as long as you're creating a scalar multiple, a collinear direction vector, you can pick whatever numbers you want that are multiples of those. Pick numbers, they're nice to work with. So -2 and -1, or the positive version of that, or even a fractional version of that. And those all work for direction vectors.